You ever wonder how your favorite apps just magically remember everything you do? It's not magic, not at all. It's a well-architected backend API. In this explainer, we're going to build out the complete blueprint that powers pretty much every modern web application, showing you exactly how the pros store and manage data. So you've just built this brilliant new application, but you've hit a wall, a huge one. When a user adds something and then closes their browser, poof, that data is gone forever. Your app basically has no memory. So the question every single developer has to answer is, where does the data actually live? Let's break this down. The approach on the left. Well, that's what we call amateur hour. Just sticking your data into some temporary list on the server. Sure, it might work for a second, but if that server so much as hiccups or restarts, everything just vanishes into thin air. The image on the right, though, that is the professional blueprint, a permanent, cloud-based database built to last. And that's exactly what we're aiming for today. So here's our roadmap. We'll start with the mission, then we'll build the foundation, design the blueprint, connect the memory, define the rules, and finally put it all into action. 6 core stages to get us to a professional, great backend. Let's get into it. First up, our mission. We need to build a backend API. Now, you can think of this as the dedicated manager for all of our data. Its entire job is to handle 4 core operations, something you'll hear called CRUD all the time. That's creating, reading, updating, and deleting data. So what exactly is an API? Well, it stands for Application Programming Interface. But for our purposes today, just think of it as a strict set of rules, a contract really, that allows our user-facing app to talk to our database over the web. It is the absolutely vital communication layer that connects the two. All right, on to stage 2, the foundation. Every API needs a home, right? It needs a server that's always online, just listening for requests from our app. So that's what we're going to build right now. And check this out. By using a super popular framework called Express.js, we can build our entire foundation in just 2 lines of code. Seriously. The first line creates our application, and the second one tells it to start listening for connections on a specific port. And that's it. Our server is officially online and waiting for instructions.
So our server's listening, which is great, but we need rules for communication. We can't just have our app shouting random commands at it. We need a predictable, structured blueprint for these conversations. And the industry standard for this is a pattern called REST.
This is where REST is so brilliant. Take a look at this. Notice how we're using the exact same URL, /API/v1/tasks, for a bunch of different actions. So how does the server know what to do? It looks at the HTTP verb. A GET request to that URL means, hey, fetch all the tasks. But a POST request to the very same URL means create a brand new task. This elegant pattern is a huge reason why REST is so dominant. It keeps your APIs clean, predictable, and way easier to manage. Okay, our API has a logical structure, but we still have that memory problem. Any data we send it will just disappear. It's time to finally fix that by connecting it to a permanent home, a cloud database. For our database, we're going to go with MongoDB. It's an incredibly popular NoSQL database. And what that means is, instead of the rigid tables and rows you'd find in a spreadsheet, it stores data in these flexible JSON-like documents. The digital filing cabinet analogy is perfect. It's powerful, and developers absolutely love working with it. But here's a little catch. Our Express server and our MongoDB database, they don't speak exactly the same language. And that's where Mongoose comes in. It's this essential library that acts as a translator, simplifying all the back and forth communication between our application and the database. So why Mongoose? Why is it so popular? You know, the source material puts it perfectly. It has an extremely straightforward API, and it basically does all the heavy lifting for us. And really, in short, it just makes a developer's life so much easier. Okay, step 5, the rules. Now, just because MongoDB is flexible, that doesn't mean our data should be a total mess. That's a recipe for disaster. To make sure everything is consistent and to prevent a ton of bugs down the road, we need to define a strict structure for what our data should look like before we save anything. Mongoose handles this with 2 key concepts. First, you have the schema. This is the blueprint. It defines all the fields our data has, what type of data they are, like text or a number, and any validation rules. And then you have the model. This is the tool. It takes that blueprint and gives us a simple, clean interface to actually work with the data. And here's what a simple schema looks like in practice.
we're defining a task here. And notice the rules. It must have a name, which has to be a string, and we're saying it's required. Then it has a completed property, which is a Boolean, a true or false value that we default to false. These simple rules ensure our data is always clean and predictable, no exceptions.
All right, we have our server, we have our blueprint, we have our database connection, and we have our rules. All the pieces are in place. It's time for the final, most exciting step, action. We're going to bring this whole API to life by implementing those 4 CRUD operations we talked about: create, read, update, and delete. Let's start with create. When a post request hits our/API/v1/tasks endpoint, our server uses that Mongoose task model we created and calls the simple .create method. And just like that, a new task is born and saved permanently in our database. Next up, read. When a GET request comes in to that same endpoint, our server uses the .find method. Mongoose dives into the database, fetches all the documents that match our rules, and sends them right back to our app. Now, to update a specific task, the app sends a patch request. But how do we know which task to update? Easy. We include its unique ID right in the URL. This tells Mongoose to use its .find first and update method to find that one specific document and apply whatever changes we sent. And finally, delete. A delete request, again with a specific ID in the URL, calls the .find and delete method. Mongoose locates that single document and just removes it from the database for good. And with that, our entire CRUD cycle is complete and fully functional. So let's quickly recap the blueprint. Your API is the messenger. REST provides the clean, predictable routes for that messenger to follow. Mongoose schemas are the non-negotiable rulebook for your data. And Mongoose models are the simple tools you use to interact with it. And one last pro tip from the source: always keep your secrets, like database passwords, out of your code and in a separate .env file. So there you have it. We've just walked through the entire professional blueprint, from the initial idea all the way to a fully functional API that can create, read, update, and delete data. This isn't just some theory. This is the fundamental pattern that powers countless modern applications you use every day. So the only question left is, now that you have the blueprint, what are you going to build?